Hi guys, this is Tsetso with yet another Phoenix tutorial, and recently I posted a video of a river simulation on Vimeo, and actually that's what I'll be building up today. I'll explain everything from setting up the scene to compositing it in Nuke. Some of the main things that I'll focus on will be the base water simulation, the foam and the splashes, the caustics, and of course rendering with render elements. And yeah. So let's start. As always, I'll start with the units dialog. So I'll just come here to the customize unit setup, and I tend to use centimeters for both display and system units for almost all of my projects. And here you can see that one unit is equal to 1 centimeter. Just press OK. And I've said this before in some of my other tutorials, but I want to say this again, that not the units but the actual size of the object is what's important for us. And if I unhide this layer, you can see that's the size of the riverbed, and it's 22 meters long, which is the important thing, and not the units. You can use meters, you can use feet, it's up to you, as long as this size here is the correct one. And if I unhide another layer, you can see this tiny little object, and if I zoom in, you can see again that's the riverbed with the stones, but this time it's only 22 centimeters long, and that's obviously wrong because you can't have a river in such a tiny area. In Phoenix, however, we've introduced a new parameter, and I'll just create a simulator to get the interface, and you can see this scene scale. It might compensate for the wrong sizes of the objects, but we do not recommend using this as a feature. Instead, what we recommend for proper dynamics is work with real scaled objects. So I'll just hide that one, and I'll create another simulator. So let's give it a size. And I will also increase the size of the cells to get lower resolution at the beginning. Okay, something like that. And I'll center it on the X and Y and move it up. Okay, and I'll rotate it so that I get relatively same angle as the riverbed. Maybe slightly downwards. Okay, so this is our simulator, and to create some water I'll need a liquid source. So I'll come here to the helpers, Phoenix FD, and pick the Phoenix liquid source. I'll rotate it. Okay, and the idea here is that I want to have this top part of the riverbed creating water that makes its way down. So to make that, I have made a selection with ID 3, which is these polygons here at the top. So they will start emitting the water, and I can come here to the source and pick the riverbed and say emit only from polygons with ID 3. I'll also set the mode to inject, and I'll increase the discharge to 100. Okay, so I'll select the simulator and press start. But I'll have to enable the liquids first. So I'll come here to the liquids tab and click the enable checkbox and press start again. And you can see that only the polygons with ID 3 are generating the water. I'll switch on the mesh preview and turn off the channels that I won't be using. And I'll apply just a standard blue material so that I can see the liquid better. And that's nice, but it would have been nicer if we didn't have to wait for that tiny stream to fill the entire riverbed with liquid, because that will take time even at low resolution, and later when we increase the resolution, that will take even more time. And to optimize things, I will just stop the simulation now and click the initial fill up in the liquids and set it to 30% and press start again. So now Phoenix will fill the entire riverbed with liquid at the first frame, and the source will do its job here at the top, emitting the water. And at this point I can increase the resolution, but before I do that I just want to tweak a couple of more parameters. So I'll hit stop, and I will turn off the wetting and the static surfaces correction, because I don't need these two for this type of scene. I will lower the sharpness to 0.5. I have prepared some images to help me illustrate better. So that's the high-res version of the liquid scene with a sharpness of 1, and you can see these areas here at the top that the grid is quite visible. So I then switch to sharpness 0.5, and you can see that now it's much better. And if you want to smooth things even more, you can use the mesh smooth in the rendering, which will smooth the whole mesh, but I generally prefer the sharpness 0.5. Okay, so I'll go to the grid section and set the cell size to 1.7, which will give me roughly 70 million cells, and I will press start. Okay, so the speed is about 30 seconds per frame, and for the total 800 frames I waited for 7 hours, and here's the result. I'm pretty happy with the detail in the mesh, and you can see it creates nice waves to the sides. And you can also probably notice that the water is faster here in the center, and that's exactly where I want to create the foam and the splashes. So that will be very easy to specify in Phoenix, and we'll see how in just a second. Okay, so I'll jump back to 3ds Max, and before I start tweaking the foam and the splashes, I'll decrease the resolution. Okay, and the idea here is to simulate the splashes together with the main liquid. And you may ask yourself why these splashes and not the foam. Well, there's two reasons actually, and the first reason is that the splashes are faster to calculate, and the second reason is that we'll be creating the foam from the splashes. So I'll just click the enable button, and Phoenix will create a shader for us. Click yes, and here it is. So I'll move it somewhere I can see it, and I'll decrease the size. Okay, select the simulator again, and one of the first things that I'll change here in the splash rollout is the size. So right now they are only 1 millimeter in size, which is very small, so I'll set it to 0.5, and I will also introduce some variation in the size. So I'll set the up to 5 and down to 10. So now I'll have splashes that are bigger than this size and smaller than the base size. Okay, so I can hit the start button now. Okay, and you can see the green dots representing our splash particles, and I'll just turn off the mesh preview for a second, and I want to generate more splashes, so I'll increase the rate, set it to 50, and you can see now that the splashes are being created all over the water surface. And as I said earlier, I want them to be created only in the center. So that's where the threshold comes in. So I'll set it to 40. And you can see now that it's harder for the splashes to get born. And if I unhide the mesh again, you can see they're being created only on the places where we have more defined shape of the mesh. And keep in mind that when we increase the resolution, these defined places will be much more, and therefore we'll have much more particles generated. Okay, and to start generating the foam, I'll just set the foam on heat amount to 1, and I'll come here to the foam tab and enable the foam. Phoenix will create another shader for me, this time for the foam. I'll say yes, and I'll set the rate to 0 because I don't want the foam to be generated directly. I want it to be created only from the splashes. So I'll set the size of the bubbles to 0.5 centimeter, the same as for the splashes. And I will also introduce some variation in the size, so I'll set the variation up to 5 and the variation down to 10. And the rise and the falling speed are the two parameters in the foam tab related to friction. And in this case I want to have less friction, so you can think of the rise speed as the underwater friction and the falling speed as the above water friction. So if I set the rise speed to 100, it will mean that the bubbles that are under the water will be able to rise up faster towards the surface because they have less friction applied. So by increasing these two parameters, you basically decrease the friction. So the same for the falling speed. I'll set this to 500, which will mean that bubbles that are flying in the air will be able to fall down faster because they have less friction. Okay, sticky is another cool parameter that I will take advantage of, and you have to keep in mind that if you want to use the sticky, you have to have bubble interaction above 0. So I'll set this to 2, and the sticky basically controls the ability of the bubbles to stick to geometry. So in this way, when a given bubble meets geometry like the stone, it will slow down instead of just sliding over it. So you'll have some nice interaction between particles and geometry there. And the bubble-to-bubble interaction, which I just mentioned, is you can imagine that when two bubbles hit one another, they will stick, and the bigger this value is, the harder it will be for these bubbles to separate. Now, this type of calculations take its time, so when increasing it, keep in mind that it might slow down the simulation. So I'll set this to 7000. And next thing is the half-life. Right now, given bubble we will leave for 10 seconds before it bursts out, so this is far more than what we need, so I'll set this to 1. And by the way, you can already see that the foam is being generated here at the center, not so much to the sides. And if I stop the preview for a second of the particles, you can see that that's where the more defined shapes of the water mesh are. So if you take a look again at this mesh, you can imagine that these places here at the center will be generating the most foam and splashes. So before I increase the resolution again, I will just stop the simulation, and I will come here to the splash rollout, and I will set the rate to 4, because again these areas where the mesh is more defined, with increasing the resolution, these places will get more, and therefore there will be much more splashes generated. So I'm compensating for this by decreasing the rate, and I can now go here back to the grid section and increase the resolution, and I can now hit start, and we'll be able to see the result with the better defined mesh and with the particles. Okay, and with almost 6.5 million particles, the simulation time is now about 2 minutes, and for the total 800 frames I've waited for 1 day or 24 hours, and here's the result. I'm pretty happy with the generation of the foam and the splashes. I also like the interactions between the foam and the geometry, like the stone here. And yeah, I think I can now start adding some lights and materials. So I'll stop this and jump back to 3ds Max. And here's the foam shader, so I'll move it just here in place and scale it down a bit. And I'll give these guys names. So this will be Phoenix foam shader, and this will be the Phoenix splash shader. And I can give these guys a color so that I can recognize them. I am almost always coloring the splash shader green because the preview of the splash is green, and the foam shader I'm giving it light color, and I'll give this source, the water source, a blue color. Okay, and I'll create a standard light, target direct. So switch to the top viewport, create it somewhere here, and I'll switch to wireframe and select the lights option so that I can only select lights. Okay, and I'll move this up to about there, and I'll move the light higher. Okay, and maybe a little to the side. Okay, so turn on the shadows, V-Ray shadow, and here in the directional parameters I'll make the hotspot bigger, and also the fall off. Okay, so that everything is catching light. And I will also go here to the shadow parameters and turn on the atmosphere shadows. So I'll take a look from the camera. Before I hit the render button, I'll select the foam and the splash shaders, and I'll turn them off from rendering for now. I'll switch them back on later, and I'll open up the V-Ray properties and switch to the active shade mode. Set up a resolution, and I'll turn off the messages. So press the active shade, move that window here, and that's the result with the direct light. So now I'll add another light, which will be a V-Ray ambient light from the toolbar. And I want to lighten up these dark areas here with the ambient light. Okay, but I'll change the color. I'll set it to 120, 130, 140, and I'm using this color a lot with the V-Ray ambient light. And the intensity is too high, so I'll set it to 0.1. Okay, and now I'll create the water material. So open the material editor, I'll duplicate this material and I'll call this water. I'll select the simulator and apply that material. Okay, so first thing, I'll turn off the diffuse color, and I'll turn on the reflections, and I'll set the reflection glossiness to 0.45. Turn on the refractions as well. I'll set the index of refraction to 1.3. Turn on the effect shadows so that the light can penetrate through the water mesh. I'll add a fog color, and I'll set this to 205, 200, and 195. And decrease the fog multiplier to 0.05. And yeah, so that will be the water shader. You can see that the deeper parts are darker and the shallow parts are not so dark, which is great. Another thing that I can do is I'll add a V-Ray HDRI to create some more reflections. So I'll load a map that I'll be using, which will be this one, and I'll set the mapping type here to spherical, of course, and I'll make the previews for these two guys bigger. Okay, and I'll rotate the map, let's say like this, so that I have more interesting parts of the image. And I'll also increase the overall multiplier to 5. Okay, come here to the V-Ray properties. I'll switch to production, and I'll apply that map to the reflections and refractions environment. And it already looks better. Okay, so I'll stop the active shade, and the next thing that I can do is actually create the caustics. So I'll close this for now, and I'll come here and create another light, and this time I'll create a target spot. So I'll create it somewhere in the viewport. I'll set the target to 0, 0, 0, and I'll align the spotlight for the caustics to the direct light, and I'll just change the hotspot and the fall off. Okay, so switch to local and move it slightly upwards so that I can select it easier, and I'll switch back to world. So the idea here is that I'm creating this light to generate caustics from it, and because I don't want to affect any other thing in the scene, I will just select the exclude list here, and I'll set it to include and include nothing, so that I'll be only using it for the caustics. So press OK, go to the V-Ray settings, and I'll turn on the caustics. I'll switch to the advanced mode, and here for the search distance, I'll set this to 2 centimeters, and I'll leave the max photons to 60, and I'll increase the multiplier quite a bit, so I'll set this to 40,000. And I'll also select the light and go to the V-Ray properties, and you can see that by default the generate caustics is turned on, and I'll set the subdivisions to 5000 here, and also the multiplier to 850. So click close, come here to the V-Ray, and I'll switch to the progressive image sampler and hit render. And you can see that we don't get any caustics right now, and the reason for that is I have to go back to the material editor, select the water shader, and I have to turn off the affect shadows. So I'll turn that off and press the render button again. And you can see that this is not the best result that we can get for caustics, and the reason for that is I'll just stop the render, that right now the direct light that we're using for the lighting is also creating caustics, so I'll have to turn this off, and the same for the ambient light. Generate caustics off, and I'll draw a region and hit render again. And you can see now that we get the caustics the way we should. Okay, great. So I'll again stop this. I'll select the foam and the splash shaders, and this time I will turn them on for rendering. open the frame buffer, draw another region and press render. And there we go. This is the foam and the splash particles. And one thing I can notice right away is that they're too bright right now. So I'll press stop. And I'll select the foam shader. And decrease the diffuse multiplier. So I'll set this to 0.55. I can also set the refraction index to 1.6. And because the camera is not very close to the particles, I can switch the mode to points so that we can speed up the rendering. And same thing for the splashes. Diffuse multiplier of 0.55, 1.6 for the IOR, and the mode to points. Okay, so draw yet another region and press render. Okay, so now this is something else. We get much better blending between the particles and the water now. Okay, so I'll again stop the rendering, and I'll open up the material editor and assign the materials that I have prepared for the riverbed and the stones. It's just a standard material with a texture applied to it, and yeah, nothing too fancy. So I'll select the riverbed and apply that material. I'll also select the stones and apply their material. And another thing that I want to say is about this layer here, the roots layer. So I've generated these tiny geometries using this plugin, and it's a plugin for 3ds Max. So you can open that page, and here at the bottom you can download for the version of Max you're using. So thanks about that, guys. Okay, so before we continue, I'll just render this whole image now so that we can see what we have. Okay, this is the final image, and it looks very nice already. But as I mentioned in the beginning, I want to compose that in Nuke, so I'll definitely need some render elements and some masks. And right now I just have the RGB and the alpha. So to add more elements, I'll go to the render settings, and in the render elements tab, I'll click the add button, which will present me with a window that contains all the elements that I can export. So in order to decide which elements I should use, I usually just take a look at the final render and try to figure out which elements are building that image, and I just output them as render elements. So in this case, I can definitely say that there is lighting, so I can select the V-Ray lighting render element, or I can build that one from the diffuse filter and the V-Ray raw lighting. So these two multiplied will give me the V-Ray lighting, and I'll use this approach because it will give me more flexibility in Nuke later, and we'll see how then. Another thing that I can see in this image is the reflections and refractions. So I'll just scroll down and add the V-Ray refraction and the V-Ray reflection. I can also see some specular highlights, so I'll just select the V-Ray specura render element. And previously I added caustics, so I will export the caustics as another render element. And the foam and the splashes are an atmospheric effect, so they will go to the V-Ray atmosphere render element. So I'll click OK, and these are all the elements that are building the final image. Next thing will be the masks, so I'll click the add button again and pick the multi-matte render element. Click OK, and these are the properties. And you can see that I have a red, green and blue buffers with some IDs associated to them. So the way this works is you assign an ID to an object in the scene, and V-Ray will create a mask for that object in the corresponding channel of the multi-matte render element. So let's say I want to create a mask for the water. I can just select the simulator, right click, object properties, and I can give the ID here. So I can set this to 1, and now V-Ray will create a mask for my water in the red channel of the multi-matte render element. So I can do this for the riverbed. I can say object properties, create a mask in the green channel, which will be 2, click OK, and for the stones also, so I'll set this to 3, click OK, and now V-Ray will create 3 different masks in 3 different channels for 3 different objects. And I also want to create a mask for the roots, so I can just select the roots, and this time I'll give them an ID of 4. Oops, ID 4, because if I open up the multi-matte again, you can see that I only have 3 slots here, so I can't add another one. But what I can do is I can add another multi-matte render element, and I can say here if I want to send the roots to the green channel of the multi-matte, I can just set the green channel to ID 4, and it will create a mask for the roots in the green channel. And I can turn off the red and the blue one because I don't use them, and I can even set them to 0 so that I can easily recognize which channel I'm using. And I will also give these guys appropriate names, so I'll call this multi-matte 1, and I'll call this multi-matte 2. Okay, so I'll hit render now, and that's what I have now. If I expand the render elements list, you can see that I have all the render elements stored here, as well as the masks. And again, RGB, alpha, the atmosphere that contains the foam and the splashes, the caustics, the diffuse filter that multiplied by the raw lighting will give me the total lighting. Here's the reflection, refraction, specular, and the masks. And one important thing here is that right now I just have a mask for the stones that are above the water, but I don't have any information for the stones that are under the water, and that will be a problem later in Nuke. Let's say if I want to change the color of the stones, I'll be able to just change the color of the stones that are above the water, and I can tell V-Ray to provide me with the information for the stones that are under the water by simply going to the material editor, locating the water material, and here in the refraction you can see that by default the affect channels is set to affect the color only, which means that the refraction will be only visible in the RGB, and I can change this to all channels, which will mean that I'll be able to distribute this refraction information in the other channels, like in the multi-matte. So I'll just draw a region to compare that and hit render. Okay, and here's the result with the affect all channels on the left and color only on the right. And you can see that by setting the refraction to affect all channels, we have that refraction information distributed in the render elements and not only in the RGB. So now I have this information visible in the caustics as well, and here in the diffuse filter. So if I come back to the multi-matte, you can also see now that I'll be able to make a selection for the stones, no matter if they're above or under the water, which will be very handy for the compositing. And one last thing before the final rendering, I will open the render elements tab again, and I'll select the V-Ray atmosphere and turn off the filtering so that we can composite that properly later. And one last thing I want to share with you is here for the riverbed material. I've increased the reflection glossiness subdivisions to 48 because I wanted to make sure that I won't end up with some flickering in the reflection. I did the same for the stones, and yeah, so that's it for this chapter. And in the next chapter I'll create some additional elements like mist and some more vegetation over the riverbed, and I will put everything together in Nuke. So see you in the next chapter.